in this episode, we are going to be talking about organic chemistry. Now, organic chemistry, just like chemistry itself, is a very big topic, very wide topic. And today we are going through the general overview of organic chemistry. So let's start. Now, organic chemistry is basically the chemistry of carbon-containing compounds. Now, these are compounds that contain their principal elements as carbon. And then this carbon is basically an element that forms a tetrahedral structure. So when we have carbon is an element that often has a maximum of 4 electrons. So carbon can bond with basically a maximum of 4 electrons. And then at times it can bond with 3, it can bond with 2, it can bond with even 1, but it must bond with at most 4. So the maximum number of elements or substituents of carbon can be 4. At times you can see them as hydrogen. So when everything is hydrogen, they are called hydrocarbons. So these are elements that have hydrogen and carbon as their principal. These are compounds of carbon and hydrogen. And today we are going to be talking about hydrocarbons and many other families. And just as a note, if you are looking for a comprehensive teaching on organic chemistry, there's another video on this in this channel that talks about organic chemistry. You can check the video out. But let me move on. Now, in organic chemistry, we have these compounds of carbon, and when we have this one substituted, we often name it differently. Now, because there are 4 hydrogens on this carbon, now this is called the methane. So this is an alkene group, and out of hydrocarbons, there are different groups of hydrocarbons. There's the alkene, there's the alkene, and there's the alkyne. There's also the aromatic or the benzene. There are also examples of groups in hydrocarbons. So let's talk about the alkene. The alkene, basically, they have a general formula of CN H2N plus 2, 2N plus 2. So basically, they have 2 elements, carbon and hydrogen, and their general formula is CN H2N plus 2. So this N can be from 1, 2, 3, 4. So if N is 1, that will be C1 H2 times 1. That's 2 plus 2, 4. That's C1 H4. That is methane. And then when we have the second member of that family, it's called ethane. The third is called propane. The fourth is called butane. The fifth is called pentane, and so on and so forth. So decane, and so on and so forth. So those are the major alkanes. Then these alkanes, it forms what is known as a homologous series. A homologous series is a family of organic compounds that have their own peculiar and special properties. For example, in homologous series, their elements, their properties, or their members, they differ by a molecular unit of CH2 or 14 molecular units, or a group of CH2 or 14 molecular units, and they have the same general chemical properties. They have the same general molecular formula, and in addition to that, their physical properties they progress successively down the homologous series. For example, methane is a gas, ethane is a gas, propane is a gas, butane is a gas. Then when we have pentane, it becomes a liquid. So from 1 to 4 of the alkane family, they are often gases. Then from 5 to 9 are liquids, and so on and so forth. So you can see that it goes from gas to liquid to solid. That is why we say in homologous series, their properties, they are gradually progressing from the top of the series to the bottom. Now, moving from alkane, these alkanes, they are relatively inactive. Because why is that is because they are often saturated. So they are always saturated. That's why they are often less reactive than other hydrocarbons. And the next one we're talking about is alkenes. Now these are alkenes. These are called alkene, ALKANE. Now we also have alkenes. Alkene, basically, they are a type of hydrocarbons that are unsaturated. So out of the 4 carbons out of the 4 spaces for elements and substituents in carbon, only 3 are used. So the remaining 1 is not used. So basically, in alkenes, you have what is known as a double bond. So basically, you have 3 substituents, and out of those 3 substituents, there will be a double bond. So for example, while we have the simplest alkene is ethene. So when we have ethene, the general molecular formula is CN H2N. So when N is 2, which is the simplest alkene, that will be C2H4. So what that means is that when we have two carbon atoms, so these carbons, they are often bonded together by double bonds. So in alkenes, you can see double bonds between the carbon atoms, but in alkenes, when you have carbon atoms, it's only single bond. So in these alkenes, this double bond, you have 2 hydrogen and a double bond, another 2 hydrogen and a double bond. So in this case, the 4 the 4 bonds of the carbon is still filled, is still complete. So instead of having just 3 substituents and 1 empty, the carbon, the 2 bonds combine to form a double bond in alkene. And the same way is in alkynes, because in alkynes the 3 bonds form together to form a triple bond. That is C, another C. We have a triple bond with another C. Then you have one bond left for substituents. That's C2H2, and that is ethyne. Now these are the 3 major hydrocarbons. We also have benzene. Benzene has a general formula of C6H6, and in that benzene you can have substituents of different atoms in benzene. Aside hydrocarbons, we have other functional groups, and in these channels I've made a video specifically about functional groups. You can check it out in this channel where I talk about organic chemistry and functional groups. But there are different types of functional groups. For example, we have the alkanols, we have the alkanoic acids, we have the alkanones, we have the alkanals, we have the amines, we have the amides, and so on and so forth. So every of these ones have their own general formula. You can check the video in this channel. But that is basically what organic chemistry is about. So and then you can often see carbon combining with 4 major elements, which are hydrogen, nitrogen, oxygen, and sulfur. So these are the 4 major substituents that often combine with carbon in organic chemistry. Thank you for watching.